This is Edict, the Atari 8-bit podcast.
They had an entire booth set up for us. Nobody had ever seen this device. But Atari just went ahead and said, okay, we're going to do this. Look, these people are going to die from that. You need to change your ways.
This is Antic, the Atari 8-bit podcast. I'm Kevin Savitz. Bill Lapham was manager of continuation engineering in Atari's consumer division. He worked at Atari from 1980 through 1984. This interview took place on April 25th, 2016.
After high school, I went to a junior college for a while and really didn't know which direction I wanted to go in, so I went into the Peace Corps. I spent 2.5 years in India in the Peace Corps, and when I came back, I really knew that I wanted to go into engineering. So I went to Cal Poly Pomona, got a master's degree in like 4 years, and then I went to work at Texas Instruments designing handheld calculators. Following that, I did some work with 8080 microprocessors and so on, and then got the job opportunity at Atari. And that's about everything in a nutshell.
All right. So how did you get that job at Atari? Did you know someone who worked there?
I really don't remember. I did know several people at Atari, but I'm not sure that had anything to do with it. I think I may have gone through a recruiter. Recruiters were big at the time, so I have an idea that I went to work for a recruiter.
Okay.
Through a recruiter.
So you were hired in 1980 or so, is that right?
Yeah, sometime around there.
And so what were you hired for initially? What was your job?
They weren't really sure what they wanted to hire me as. In other words, they didn't have a title. We had to come up with a title. But the thing was, we had a design team that was going in and doing initial designs. Once the initial design was done, let's talk about the first Atari computers. The first designs were done by a design team, Don Lang and his crew, and then at that point, they needed somebody to continue the design into the future. They didn't want to spend design resources on it. For example, if we had a microprocessor design and there were new and improved versions of an Intel 8080 or 8008 or 4004 chip, it would be my responsibility to incorporate that into the design, both cost-cutting and improving performance. So they came up with, or we came up with a title of continuation engineering. I had a group of, 5 engineers and about 4 technicians that did continuation engineering, and we would interface with the vendors around the world to get new and improved components for the computer.
Okay, and then make sure they worked in the new computer after you had them on hand.
Right. We do complete testing of them, temperature testing and so on and so forth. The other part of my job was to get international registrations for them. For instance, UL, Underwriters Laboratory, CSA, Canadian Standards Association. We took them to Europe and got certifications in Germany, Australia, you name it. Wherever we needed a certification for radiation, for electrical safety, It was up to continuation engineering to do that.
So did you physically take a couple of machines to Germany or wherever and wait around while they tested things? Or what? How did that work?
Yes. Well, eventually we built our own anechoic chambers to test the electronics in, and that was for radiation. We wanted to ensure, or the FCC and other agencies around the world wanted to ensure that our computers would not interfere with the other electronic signals around various places. The first case of this came up rather interestingly in Reno, Nevada, where a police officer was called to a casino because of a problem, and they found that all of the slot machines that were now electronic, which was basically a computer, their radiation, their radio transmissions from within the cabinet were interfering with the radio, and the police couldn't communicate with each other. So the FCC came up with these standards, and they just blossomed around the world. So we would have to take our computers and other devices to what we called an open field test range. And the most prominent one was up in the mountains in the Sierra Nevada, where you would find a place that was basically dead, no radio signals or anything else, and we would set up and actually listen to see if there was a radio transmission out of the computer. And we would have to minimize that to a certain standard. So we did this around for places around the world. Now, I did test in Australia once and in Canada once, but for the most part, we could just send them and have them tested there.
Nice. Do you remember any instances where you needed to make significant changes to the hardware to keep RFI to minimum?
Oh, yes. The first computers that we had to test, we would take a printed circuit board, like a multi-layer motherboard, and in the computer and turn it on, and there was nothing but interference on, every possible frequency. And so we had to start putting metal cans around things and basically enclosing the motherboards. When we got into real fast display technologies, we had to shield the displays. We had to shield cables. We really learned a lot in those days about RFI, EMI, and what we had to do to prevent it. So that really built upon itself. We would incorporate that in the upcoming designs, and that's part of what continuation engineering was all about. We would find these fixes and feed them back to the design teams, and the design teams would incorporate these things from the beginning. So we didn't have to reinvent the wheel every time we came out with a new product.
So you're in charge of that giant metal box that's around all of the internals on the Atari 800, sounds like. The thing that made it so heavy and just heavy.
Yes, indeed.
All right, so
and a lot of that technology is still used today. If you think about smartphones today, if you open up a smartphone, you'll find that the plastic cases are coated on the inside with a metallic coating, and that's basically what the enclosing can is today. Back then, all we had was sheet metal to bend up, and now we've got spray-on technology.
Right. So you were there for when they were creating the 1200 XL, I believe, correct?
Oh, yeah.
So can you give me an example of design changes that happened there? I mean, it's a much lighter machine, for instance, doesn't have the cage. So what did you learn to change to create that second generation of hardware?
Well, we learned a lot more about designing. It was basically how we designed the printed circuit boards. The initial printed circuit boards that we did were just a couple of layers back in the days when we first came out with both the gaming machines and the computers. After that, we found that we could put in several grounding layers within the printed circuit board, as well as power planes. So we had power and ground, and they were on the outsides of the board, and the data transmission lines were inside the board in multiple layers. I think about that time we could go up to like six layers. So that really brought down the amount of metal we had to put on the outside as shielding, because the EMI was reduced quite a bit. But we were adding more capacitors in, and it got down to the point where every chip had a capacitor on it, just to minimize EMI. And then the next thing that happened is we needed to have the systems immune to all kinds of outside forces like lightning and, that kind of thing. So we found that as we got into CMOS, we went away from TTL technology into CMOS, we had bigger and bigger problems with static electricity. And we had another problem there. So it was a continuous design effort to improve and minimize things that were happening to the consumers.
Interesting. So you had mentioned initially one of the first things you said was part of the job was integrating new versions of components. And I'm wondering if you have any memories or examples about any sort of, a new chip that came out that caused a problem, or power supply parts, or just anything that give me an example, basically, of that.
Well, as things changed in the electronics, for instance, I said as we went from TTL to CMOS, that the requirements for the power supply came down. Now, we had a lot of stuff where initially we had the power supply built on board. But as the power requirements diminished, we came up with the lump in the cord, as we called it. Some of them called it a baked potato. But it's very common today to have a device that plugs into the wall. We have the AC cord running into a big black box, and then a smaller cord that runs out into the computer or whatever device you're powering. Those developments came from developing new power sources. For instance, we went from bridge rectifiers and that kind of thing into switching regulator power supplies. And the switching regulators would step up or step down. A lot of them were transformerless, and a lot of them were just a brick that we filled with epoxy and used that for heat dissipation, various things like that. Mm-hmm. And then, in addition, because it was a switching regulator, I hope I'm not getting too technical here, but
no, that's fine.
It used high-frequency switching, and that high-frequency switching added more problems, because now we had this box that was outside the computer that had to be EMI tested, and we fixed that by putting ferrite cores around the power lines and so on, and that minimized the amount of radiation. So there were these kinds of things when we got into, if you remember, the first computers that we had, the devices we used for storage, memory, was a tape recorder.
Right.
And like there was nothing like a floppy disk that was affordable on the market. So we used an audio tape recorder that was being built in the Far East, and so we would improve on the audio tape recorder. Of course, we didn't need the audio quality and so on, so we would go over to a manufacturer and sit down with them and work with them to have them reduce the component count and to minimize what was needed in that circuitry. That way we got a cost reduction and a performance improvement at the same time. So when we finally got away from the tape recorder into the floppy disk, it was a whole new world because the floppy disk acted totally differently, and it was digital, and so it was a complete game changer for the way we had been doing things. Also, memory. Memory devices were quite expensive at the time, but there was a lot you could do with like 64K of memory in the early machines. I'm a ham radio operator, and with 64K of memory and the inputs and outputs that Atari used, I built a satellite tracker. At the time, ham radio operators were putting on small transceivers on satellites, and as they would go over, you could bounce signals off of them and talk around the world. Well, we found we used the equations for the path of the satellites and drove antenna arrays with a 64K Atari computer that would track these things across the sky, and we could talk to people around the world with them. It was really fun in those days to do things other than just games.
Sure. Yeah, I remember reading back in those days that ham radio operators loved the Atari machines because they were so well shielded against RFI that it didn't leak into your receiver.
Absolutely, yeah. It was, you could have them sitting right there next to your radio, and it caused no interference at all.
Nice. And you mentioned the epoxy in the power supply bricks. I just need to say that epoxy is still a problem today, because when some of those bricks now, they're just filled with the epoxy or whatever you guys did, and when they break, you just got to throw them out. They just cannot be fixed because of the epoxy.
Right. It was a mess, and they were all built overseas. There was one manufacturing plant, just as a side note, in Taiwan that I had to visit like every 2 or 3 months. And I walked in one day, and they were building these power supply bricks. And the people on the line were pouring epoxy and smoothing it out and, so on and so forth, with bare hands. And so we had to have kind of an OSHA sit-down meeting and saying, look, these people are going to die from that. You need to change your ways. And so we also then became the continuation engineering part of it, became the facilities inspectors for overseas. If we saw anything overseas that was environmentally unsafe or, caused a problem, we could shut the line down.
Wow.
So we had a lot of responsibility.
Well, that's super interesting. Can I have more examples of that? Did you ever have to shut the line down for other things?
Absolutely, yeah, absolutely. And we also had to go surprise inspections because, for instance, this power supply small fiasco we had with these people using the epoxies. We found that every time we walked in there afterwards, everything was clean and nice, and nobody was doing anything wrong. But we accidentally pulled a surprise inspection one day and walked in, and they hadn't changed anything at all. So we actually got rid of that company. We fired them and brought up another one. Of course, at the time, there were dozens of companies in Taiwan that we could pick up at a moment's notice. But we had facilities in Singapore that we had to inspect, and Atari Wong was in Hong Kong, and they were our major manufacturing arm in the Far East. So Atari Wong was our soulmate, if you will, in carrying out a lot of this stuff. I would come up with all the procedures and the things we needed to do, and they would execute them. So I would go over there about every 2 to 3 weeks and spend a week with them and, monitor what was going on, carry changes over, and things like that.
Wow. Was it a management edict that things overseas were supposed to be done right, or was it just you guys felt that it needed to be done right? Where was the balance, the scale tipping on cost savings versus not letting people die from manufacturing computers?
I think it started out being a concern on our part. The people that were seeing this going on saying, we'd never let that happen in the United States. And then upper management said, when we let them know that this stuff was going on, they said, we shouldn't let that happen. So it became a corporate edict that if we saw anything, we'd do something about it. Mm-hmm. And we wouldn't necessarily use these people over there in their manufacturing facilities for everything we could get out of them. There were some limits to what we would allow to happen. So I think there was the beginnings of the movement to make everything equal.
That's nice to hear. So you're there for the 400, the 800, the 1200. What other machines did you have a hand in?
Well, I think the one that I am most proud of is a little something called the Mindlink.
Mm-hmm. Yeah, I know some about it, but please tell me about that.
Okay. It was rather interesting how it came about. A fellow named Jim Scudder, who lives in, I believe, Virginia, came banging on Atari's door one day, and he says, I got something really interesting here that I would like you guys, to think about and work with. And what it was a headband. And the headband you could put on, and there was something called myoneural feedback. And basically what that means is if you think about something, your brain generates a mild electrical signal, and it causes the muscles to move. So he said, well, we're going to use FET amplifiers and pick up those signals and control a computer with it. And we said, okay, sure. Um, he didn't know how to do it. He just had this idea of doing it. He had basically the headband figured out, but how to interface it to the computer, he had no idea. So, you know, Atari was doing other things, and so they came to me and they said, hey, would you like to try to do this? And I said, sure. And that was in, let's see, late 1983, like in December or early 1984. And so they said, what are you going to need? And I said, well, look, give me one marketing guy, one technician, and give me $50,000, and I'll go to Hong Kong, and we'll come back with it. And that's basically what we did. The idea was to take this headband and run it down to a controller that had an infrared signal. The infrared signal would be passed across the room, for example, and picked up by a receiver that was plugged into the joystick controller port of the Atari, be it a gaming machine or a computer. And because we had both analog and digital signals, input and output there, we could then control the system. So it was rather interesting. In the beginning, we put on the headband, and anybody could put on this headband, and it would make contact with the forehead. And if you raised your eyebrows, we could get the paddle to move clear across the screen. Lower your eyebrows, and it moved back. You could also clench your jaw, and it would move. And so there were various movements that you could get by just doing those facial expressions. But the interesting thing was we had to put an amplifier on it. Initially, the signals, if you really clenched your jaw or, you know, furrowed your brow, you could get the paddle on the screen, like for playing Pong or what was that one where you broke down the
Breakout?
Oh, Breakthrough. Mm-hmm. Okay, you could get that to just go bang, bang across the screen. But we found that we had to cut down, as people learned how to use it, we had to cut down the amount of amplification because it took no movement at all. It just took thought, essentially, to do it. And we finished the day before the CES show opened in Chicago. Now, when they opened in Chicago, they had an entire booth set up for us. Nobody had ever seen this device. But Atari just went ahead and said, okay, we're going to do this. And my marketing manager, Anthony Jones, and I arrived. We put on the headbands, and what we had was in the booth, we had TV monitors behind us that had, I believe it was Pong going. But we also, as we faced the crowd, we had TV monitors in front of us so we could see what we were doing. And as we talked, we played Pong with these controllers. And it just hit nationwide. I mean, it was on Good Morning America. It was on USA Today. Their headline story, it was in the Wall Street Journal. I mean, this really was a breakthrough. And the next day, I can't remember his name. I think it was Gregory. At any rate, he was the commander, the black commander on one of the space shows that were on television at the time.
Okay.
At any rate, he came up to the booth and said, "Can I talk to you?" And I said, "Sure, let's," you know. And Anthony and I went to our booth office, and he was there representing Rose Kennedy. And I said, what would Rose Kennedy want with us? And he says, we love the idea of this headband controller, and we would like you to develop it for Special Olympics.
Wow.
And we said, well, geez, we can do that. And he said that Rose Kennedy was willing to give us $500,000 in development money to do it. And so we, said, sure, we'll do it. And we returned to Atari and sat down, and we got some software designers together, and, man, we were really chugging. And then, if you'll remember, Atari was sold. And amongst the things that were thrown away were the headband controller, because the new owners decided that they wanted nothing but computers. They didn't want any games. You know, this wasn't the kids' thing. It was going to be a computer, and they were going to take down Apple in a very short term. So they got rid of all my people. They didn't get rid of me, but they got rid of all my people. And in a short time, they, just completely devastated the Atari Brain Trust and everybody else. And I kind of left about, I guess it was 3 weeks later, when I went to work for Silicon Graphics. I couldn't remember. But I went to work for Silicon Graphics and did their basically continuation engineering there.
So why did you leave? Were you disgusted with the tray mills, or?
Yeah.
Yeah.
They had not a clue as to what we were doing and why it was so significant, like the headband controller. If you think about it, we now have the Wii and other devices like that came out 20 years after we got a start on it. This was the beginning of the Wii type controller, this headband, and we did come out with immediately. We came out with games because we figured that we could sell games more than we could sell other things. But we also had some software that was used for relaxation. For instance, alpha and beta wave recognition. We could read the alpha and beta waves in your brain, and we could teach you how to relax and bring those alpha and beta activities way down. And that was mind-blowing, if you will.
Wow. That's amazing. What haven't I asked you about those times that I should have?
Oh, I don't know. There were some funny things that happened.
Tell me a story.
Well, it's written other places, but just before I arrived at Atari, there was an incident that was rather interesting historically. One of the head engineers, name of Don Lang, had hired on this technician, and the technician was, a fairly interesting fellow. He did his job well, and the way Atari worked is we had a big laboratory, and all the techs were in that lab, and the engineers would walk in and say, okay, make these changes, do that, and, so on, and walk away. So they'd come back later and say, well, is it done? And yeah, it's done, here you go. So one night, I was actually walking through the lab, and I see this guy sitting there, and a guy sitting next to him. And I, didn't think too much about it, but Then a couple of days later, I walked through the lab, and here was one of those fellows, and he had his feet up on the lab bench, and he was basically reading a book or sleeping. I don't remember exactly what it was. And I went to Don and I said, "Look, this guy is not doing the work he needs to be doing." And so Don, checked it out, and sure enough, they fired him. Well, it turns out that the guy that was hired and was there during the daytime was named Steve Jobs. The guy that was there at night and was doing the work was Wozniak. They were double teaming it. Jobs didn't know one end of a soldering iron from another. Wozniak did. And so at night, all the work got done, and during the day, when somebody would come in and say, "Where is this, piece of circuit board or whatever?" "Oh, it's right here." Okay. So that is one of the more interesting stories about Atari. The other thing was that every Friday night, Atari had a beer bust out in the parking lot. At 5 o'clock, everybody kind of, went out and ate pizza and drank beer and had fun. And it became rather interesting because they're on our First Street, and I've forgotten what the corner was, but the building right there on the corner of First Street and whatever it was had been a gymnasium. Yeah. And in the back of that building was a complete spa. A big whirlpool and gym and everything else. And the parties could get kind of wild. And that's about all I'll say about that. But
No. You need to keep going. Did you go to these parties? Did you enjoy the hot tub?
Everybody went.
Yeah?
Never used the hot tub, but there were times that there were multiple people in the hot tubs that I heard about. And, I actually looked through one of the glass windows in the doors one time, and there were just bodies all over the place. But, it was a different time. Right. Those were in the mid-'80s, and, you couldn't do anything wrong, and money was just flowing. And Atari made history in those days with its demise, because I think, if I remember correctly, in one quarter they lost $850 million. I don't know why. I never really could understand why Atari went down as hard and fast as they did, but they did. They just couldn't sell their products, I guess. But that was the high point, the parties every Friday night, and that was not uncommon around Silicon Valley. Everybody did it. HP and Intel and all the big names were having parties like that every Friday night. And it really came to a halt when a couple of people, I can't remember what company it was, couple of people got pretty well soused and got on the freeway and killed themselves. And all at one time, all of the parties in the Silicon Valley stopped, just dead in their tracks, and there were no more beer busts, and we would have pizza sometimes, but none of the big parties that lasted until 1 and 2 o'clock in the morning. But that's all there was hard work and hard play.
Yeah. Awesome. If you could send a message to the people who are still using their very well-built Atari 800s today, what would you tell them?
I would tell them party on. They're good machines. They're fun to play with. I've got mine, and I've got a box full of cartridges that, including ET, and a lot of them are experimental, and they're so fun to play with. The joystick and all that. You can have all the battles you want out in outer space and so on, but Pong and games like that, I put them up on the big screen TV, and they're a lot of fun to still play, and the kids just love them too.
Nice.
So I think that I think there's a lot to be said for those old games, and how much fun they were.
Yes, indeed. Nice. So do you think you have any carts that were stuff that was not released or non-production versions of software that needs to be archived?
They have already been archived. Everything that I had, we duplicated and put in the archive. And I believe, I'm not sure where they are. And I've even forgotten who did them. But shortly after everybody left Atari, we just kind of, I know one of the marketing people, Sherry Horowitz, who is down in Southern California now, had a bunch of them, and we duplicated those. So there were copies of them made and stored away, and exactly where they are, I can't tell you.
Okay.
I've got a few of them that we developed.
Well, hopefully they've made it out into the world of the internets and stuff. I bet they have by now. Nice.
Yes, indeed. I hope so. I've never really looked for them now.
Well, I think I have what I need. Thank you so much. This is great.
All right. If you need anything else, you've got my number. It was a pleasure talking with you.
If you enjoy these interviews and would like to contribute something, I encourage you instead to donate to one of our favorite organizations, the Internet Archive, at archive.org. The Internet Archive is a nonprofit digital library with the stated mission of universal access to all knowledge. They've done incredible things to preserve computer history, including hosting thousands of programs in an in-browser Atari emulator, creating the Wayback Machine, and offering full-page scans of countless Atari computer books and magazines. Make your tax-deductible contribution at archive.org/donate.